This is Group 20, and today we'll be presenting on traditional model of memory. What is a memory? Memory can be defined as the act of remembering or the process of taking information from the events around us, processing it, storing it, and later recalling that information or visual display over a short period of time or years later. Memory can also be defined as the storage of information, signals, and stimuli received by our five senses and the retrieval of this stored information. The traditional model of memory. There are some crucial models of memory. In the mid-1960s, founded on the facts accessible at the time, researchers planned a model of memory differentiating two constructions of memory initially put forward by William James, that is, primary memory, that carries impermanent details currently in utilization, and secondary memory that carries details forever or at the minimum for an extremely long time. Richard Atkinson and Richard Schifrin planned a distinctive model that envisioned memory with regards to three memory stores. 1. Sensory store, competent of keeping comparatively restricted quantities of details for extremely small term intervals. 2. Short-term store, competent of keeping details for moderately longer intervals but of relatively restricted capacity also. 3. Long-term store, of extremely enormous capacity, competent of keeping details for extremely long intervals of time, perhaps even forever. Sensory store. This store is the first origin of ample details that finally invade the short and long-term stores. Powerful proof says in approval of the actuality of an iconic store. The iconic store is a well-defined optical sensory listing that keeps details for extremely small intervals. Its title is obtained from the place that details are kept in the fashion of icons. These, in turn, are optical depictions that constitute an object. Icons usually favor anything that is being depicted. Sperling's test is utilized for the sensory store.
Sperling's test. In 1960, George Sperling implemented experiments that were aimed at demonstrating the existence of visual sensory memory. He also explored the duration and capacity of this type of memory in his experiments as well. On the next slide, there is a video clip that further explains Sperling's test. And on the slide thereafter, there is a practice session that you can use to test yourselves via this method.
All right, this recording is going to be about the first step of our information processing model, which would be encoding, getting information into the brain, and specifically how encoding matches up with Atkinson and Schifrin's model. Their first step of how memory works talks more so about effortful processing, and specifically their first step is going to be sensory memory. So here we're going to look at sensory memory from a couple of different perspectives, but mainly we're going to be focusing on the capacity of sensory memory and how much information we can fit there, and also how long information lasts once it's in sensory memory. So looking at the definition of sensory memory, we see that it's that very, very brief, immediate recording of information. And the place that information is recorded is known, at least theoretically, as your sensory registers. So these are those entry points for raw information from the senses. Now I say theoretically, sort of metaphorically, you don't have an actual location where sensory memory is stored, but if you see this kind of in a textbook or on the AP exam, we're just talking about kind of where information goes from the external world into your memory system. Now, there was a guy who looked at how long information lasts in your sensory registers, his name being George Sperling. And he wanted to study specifically the rate of forgetting from your sensory registers. And so, in order to do this, what he did was he designed an experiment. And in the experiment, participants were brought into his lab and they were shown a picture. And this picture was a matrix of letters. 9 different letters were presented in 3 rows. And he flashed this to his participants for about 1/20th of a second. And what he found was that if he asked them immediately after how many of those could they recall, they would maybe be able to recall approximately half of them. And so he thought, well, that doesn't seem like sensory memory is that good. But then he thought about it and he said, well, maybe the problem is it takes them too long to recall them immediately after. That by the time you've listed kind of 1 or 2 or 3 of them, the rest of them have already faded from your sensory registers. So he performed a separate experiment, and what he did was he showed them the same series of letters, but this time he had told them, I'm going to sound a tone right after you look at this picture. And it's either going to be a really high tone, a medium tone, or a low tone. If you hear a high tone, that means you're going to list for me the letters in row 1. If you hear a medium tone, row 2. If you hear a low tone, row 3. And so when he sounded the tone immediately following showing them the letters, he found that recall was close to 100% for the line they had been indicated to recall. And so this demonstrates that your sensory memory can capture a whole lot of information, but that information fades really, really quickly. Like I said, if the tone was sounded immediately, recall was 100. If you waited even 1 to 2 seconds, recall really declined and really plummeted because it wasn't very good because information had already faded.
Here is the practice session. Right, that is the end of that session. We'll be heading into short-term memory store. Primary or active memory is another name for short-term memory. It has the ability to retain a limited amount of information in the mind and keep it accessible for a short period of time. The capacity of short-term memory is limited and restricted. Short-term memories only endure a few seconds if they are not practiced or actively maintained, and is thought to be limited to 7 objects at a time within a range of plus or minus 2. In terms of its duration, the majority of information held in short-term memory will be lost after 20 to 30 seconds, if not less. Some knowledge can persist up to a minute, but most information decays rapidly unless you utilize rehearsal tactics like stating the information out loud or mentally repeating it. Short-term memory information is more vulnerable to disruption. New knowledge can quickly supplant old information. Short-term memory issues can also be caused by similar things in the environment. An example of this is if you're in a loud, noisy place, or if you're thinking about what to say to someone rather than paying attention to their name, you can have a tougher time remembering their name. Another example is trying to recall the details of a book that you have read days ago. While many short-term memories are quickly forgotten, attending to this information allows it to continue to the next stage, which being long-term memory. As it pertains to capacity, short-term memory capacity varies. In 1956, psychologist George Miller proposed that humans may store between 5 and 9 items of information in short-term memory in a study titled The Magical Number 7 plus or minus 2. This may explain why humans can recall objects with more than 7 digits, such as mobile phone numbers. We split the information into groups while trying to recall a phone number with 11 digits. The technique of orally or mentally repeating knowledge in order to increase the duration of short-term memory beyond 30 seconds is known as maintenance rehearsal. An example of maintenance rehearsal occurs when you're trying to repeat the digits of a phone number long enough to make a call. The knowledge is quickly lost from short-term memory if it is not rehearsed or repeated until it is committed into memory. How does short-term memory become long-term memory? A memory is transferred from short-term to long-term memory in order to be retained. The actual processes that cause this are still debated as they are also unknown. According to the multimodal concept, all short-term memories were transferred to long-term memory naturally over time. Researchers have postulated that some mental editing takes place, with just a few memories being chosen for long-term storage. Time and interference can affect how information is maintained in memory. Maintenance rehearsal can assist in the transition of memories from short to long-term memory. This method might be used, for example, when studying for an exam. Instead of merely going over your notes once or twice, you can just go over them repeatedly until the important information is ingrained in your mind. Another example or another way that short-term memory becomes long-term memory is through the use of mnemonics. Mnemonic phrases, acronyms, or rhymes that are easily recalled can assist in shifting short-term memories into long-term memories. Among the most common instances of mnemonics are Roy G. Biv, which is the initial letter of each color of the rainbow, or 30 Days Hath September, which is a poem that is very useful in recalling the number of days that a month has for each month of the year. Another way in which we can convert short-term memory into long-term memory is through the use of chunking. This is a type of memorizing strategy that helps in the transfer of information from short-term to long-term memory. This method entails grouping information into easier to understand groupings, words, phrases, or figures. The chunking approach is used when huge jobs are broken down into smaller time pieces. When learning a new task, we usually break down the instructions into steps and then go through each step one at a time, pausing in between. Long-term memory store. This memory store holds memories for an indefinite period of time. When the short-term memory is rehearsed, it is then turned into long-term memory. The long-term memory has unlimited capacity and duration and encodes information semantically, but it can also be visual and auditory. Information from short-term memory can be transferred to long-term memory by means of rehearsal and back again to short-term memory. When the information being stored is given meaning, it is passed onto the long-term memory. Elaborative rehearsal is the process of linking new information in a meaningful way with information already stored in long-term memory. And here is a diagram that shows the two types of memory under long-term memory, and it further branches out to what falls under each category. Long-term memory is usually divided into two types of memory: explicit and implicit memory. Explicit memories, also known as declarative memories, include all of the memories that are available in consciousness. Explicit memories can be further divided into episodic memories, which are specific events, and semantic memory, which is knowledge about the world. The encoding of explicit memories is done in the hippocampus, but they are stored in the temporal lobe of the brain. Episodic memory is a part of the explicit long-term memory responsible for storing information about events that we have experienced in our lives. It involves conscious thought and is declarative. An example of episodic memory would be a memory of something that happened on your first day at school. The knowledge that we hold in episodic memory focuses on knowing that something is the case. For example, we know that we have group assignments to complete, or we know that we have tests to study for. Semantic memory is a part of the explicit long-term memory responsible for storing information about the world. This includes knowledge about the meaning of words as well as general knowledge. It involves conscious thought and it is also declarative. The knowledge also focuses on knowing that. For example, we know that London is the capital of England and Kingston is the capital of Jamaica. Implicit memories are those that are mostly unconscious. Several brain areas, which include the basal ganglia, parietal, and the occipital regions, are involved in implicit memory. This type of memory is largely independent of the hippocampus. Implicit memory includes procedural memory, which involves memories of body movement and how to use objects in our environment. It also includes associative memory, non-associative memory, and priming. Procedural memory is a part of the implicit long-term memory responsible for knowing how to do things. That is, memory of motor skills. It does not involve conscious thought and it is not declarative. Procedural memory would involve the knowledge of knowing how to ride a bike, for example. Associative memory refers to the storage and retrieval of specific information through association. It is the ability to learn and remember the relationship under unrelated items. This type of memory is carried out with two types of conditioning: classical and operant conditioning. Classical conditioning refers to the learning process in which stimuli and behavior are associated, while operant conditioning is a learning process in which new behaviors develop according to consequences. Non-associative memory refers to the learning of new behaviors mainly through repeated exposure to a single stimuli. The new behavior is classified into habituation and sensitization. Habituation is the decrease in response to repeated stimuli. For example, hearing a loud banging noise from your neighbor's yard. The unusual sound would draw your attention immediately, and you would begin to wonder what might be making such a noise. Over the next couple of days, when the noise becomes regular, as such, you will tune out the noise eventually. Whereas in sensitization, it is an increased response to repeated stimuli. For example, hearing a loud crash, which would startle you upon hearing said crash. Priming is a technique in which the introduction of one stimulus influences how people respond to other stimulus presented later. Priming works by activating an association in memory just before another stimulus or task is introduced. An example of priming would be exposing someone to the word blue, as this would evoke a faster response to the word sky than it would to unrelated words such as television and radio. This would be the case as blue and sky are closely linked in memory, and therefore people would respond faster to that than when the second word is presented. Information stored in long-term memory usually remains there for the rest of the person's life. However, this does not mean that the person is always able to remember the specific information. While some long-term memory tend to spring quickly to mind, others are weaker and might require prompts, cues, or reminders to bring them into focus. Information of greater importance leads to a stronger recall. You usually remember more important events that happened in your life than what happened to you on an ordinary day. How long-term memories form and change. The information processing model of memory characterizes human memory much like a computer. Information enters short-term memory, then is transferred to long-term memory, much like information being stored on a hard disk of a computer. Memories that are frequently accessed become stronger and easier to recall. Accessing these memories continuously strengthens the neural networks in which the information is encoded, leading to an easier recollection. When information is needed, it is brought out forth of the long-term memory using environmental cues, much like accessing a saved folder from a computer. Memories that are not recalled often can sometimes weaken or be replaced by other information. When these long-term memories weaken or have been replaced, it is called long-term memory loss. The term long-term memory loss refers to the difficulty in recalling said information. Some signs and symptoms of long-term memory loss have been included on this slide. There are many causes of long-term memory loss. These causes can be classified as reversible and irreversible causes. Reversible causes can be treated. Some of these causes include depression and anxiety, vitamin B12 deficiency, androcephalus, and mental health issues. In other cases, long-term memory loss can be the result of brain injury. The causes of brain damage include but are not limited to alcohol, brain infections, brain tumors, a stroke, oxygen deficiency, and drug abuse. Irreversible causes of long-term memory loss include the following: Alzheimer's disease and dementia. Alzheimer's disease causes memory loss, difficulty in comprehension, reasoning, and judgment. The first symptom of dementia is short-term memory loss, which is then followed by long-term memory loss. And here ends our presentation. The following are our references that we used for this presentation. Thank you so much for your time.